This was a very conceptual MCQ that was tested, and I think I've already done it in the 2024 past paper session. Yeah, I have. I don't think I have done it. But saying what's the formula of magnetite? And he says that magnetite is an ore of iron which contains the Fe2 plus ion, the iron 3 plus ion, and the O2 minus ion only. So it must have a 2 plus, it must have a 3 plus, and it must have the O2 minus ion. Remember one thing, that whenever you have an ionic compound, like for example Fe2O3 or MgO or NaCl, the reason why that's the formula for it is because for if you look at NaCl, for one sodium ion you need one chloride ion. If you look at MgO, magnesium has a charge of 2 plus and O has a charge of 2 minus. So for one magnesium ion, one O2 minus ion is required. And the reason for all of this is because the charges balance each other out. So for a 1 plus, you need to have at least 1 minus. For 2 plus, you need to have 2 minuses. Then, sir, why is MgCl2 the formula for magnesium chloride? It's because magnesium, since it has a charge of 2 plus, and chloride ion has a charge of 1 minus. How many chloride ions are needed for one magnesium 2 plus ion? Obviously, you need 2 chloride ions to balance the charge. So 2 plus is now balanced by 2 negatives, right? Although chloride ion has a 1 minus charge, but you need 2 of these in order to balance these charges. Similarly, if you look at Fe2O3, the reason why the formula is Fe2O3 is because if you look at the iron 3 plus ion and the O2 minus ion, you need 2 iron 3 plus ion and you need 3 O2 minus ions to balance the charges. So 2 times 3, that's 6 plus, and 3 times 2, that's 6 minus. So that's the idea behind formulas. Cross multiplication is just a technique, it's just a trick, right? And those students who were just used to cross multiplication probably went for B, Fe2O3. But it must have, this ore must contain Fe2 plus, Fe3 plus, and O2 minus. So if you look at Fe2O, do the charges balance each other out? So you have 2 plus, you must have a 2 plus and a 3 plus. That's true. Now, how many 2 pluses and 3 plus? We don't know that. But if you still balance these charges out, there's one O and there's 2 irons. So I could say, hey, both one of the irons is 2 plus and one is 3 plus. Is 5 plus balanced by 5 minus? No. So A is incorrect. Similarly, you have 2 iron ions here. So one must be a 2 plus and the other must be 3 plus. And you have 3 O2 minus ions. So in total, how many negatives do you have? A 2 minus, a 2 minus, a 2 minus. So in total, you have 6 negatives. So is a 6 minus balanced by a 5 plus? Absolutely not. So B is also incorrect. Fe3O2. Now, if you look at Fe3O2, there are 3 iron ions, right? So 2 plus and 3 plus is a must, but the third iron ion can be a 2 plus, or you could say, hey, a 2 plus and a 3 plus is a must, but the third iron ion can also be a 3 plus, right? So there are two possibilities. Either the third iron ion is a 2 plus or it's a 3 plus. But one 2 plus and one 3 plus must exist. That's what it says right here, that it must have a 2 plus and a 3 plus and an O2 minus. Now, oxygen is in group what? Group 6. So it has a 2 minus charge. So if you have 2 oxygens, that means you have a total of how many negatives? It's a 2 minus and a 2 minus. So in total, you have 4 negatives, 4 minus. So is 4 minus balanced out by 2 plus 2? That's 4. 4 plus 3 is 7. Is 4 minus balanced out by a 7 plus? No, it's not. That's not true. And again, is a 4 minus balanced out by an 8 plus? No, it's not. So C is also wrong. And then D is the only option left. And why is D correct? Because again, there can be two options with Fe3. There can be two options. Obviously, a 2 plus and a 3 plus is a must, but the third ion can be a 2 plus, and a 2 plus and a 3 plus is a must, but the third ion can also be a 3 plus, right? And how many O's do you have? You have 4 O's. So a 2 minus, a 2 minus, a 2 minus, a 2 minus. That means you have a total of 8 minuses. Now, 2 plus 2 plus 3, what do you get? 7 plus. So is 7 plus balanced out by 8 minus? No, sirree. So it seems that D may not be our option. But if you look at the second option, you obviously have an 8 negative with the oxygens. But if you look at the second option, it's a 2 plus, 3 plus, 3 plus, 3 plus 3, that's 6, 6 plus 2, that's 8. And absolutely, it makes sense. So now you even know the composition of Fe3O4. The composition of it is what? It's you have 1 iron 2 plus ion, you have 2 iron 3 plus ions, and you have 4 O2 minus ions. And that's the only way that the positives balance out the negatives. Yeah, pretty easy, huh?